In this video we will see how we can create a very precise 3D object with the Mavic 4 Pro with the 100 megapixel image size or the 25 megapixel image size of the Mavic 4 Pro. We use Reality Scan and DJI Fly and the map creator in this video. For this barn I used a double helix mission with elevation and also a grid mission cross. Here we can see the 2D mission, that's the elevation helix mission, and then a circle around the barn, and then some local images here to get all the details from the barn, and also here on the roof. It's important that you get down and take some images up to the roof. What we can see here, it's a very good result. I took the Mavic 4 Pro for the images. I didn't use the full resolution of the Mavic 4 Pro. The Mavic 4 Pro is capable with the DJI Fly missions to use the 100 megapixel image, but I shoot this one with the 25 megapixel. We can see here the individual images from this shooting with the 25 megapixel resolution from the Mavic 4 Pro. Now let's start with Reality Scan. It was named before Reality Capture. We have some new workflows. Mask the images. That's interesting if you have small 3D objects, but for the Terra objects I recommend not to use to mask the images. We can later, after alignment of the images, adapt the size of the rendering. Now the first thing we do, it's like in Reality Capture, it's always the same. We take all the images. So actually I have 392 images from the Mavic 4 Pro, and then we align. We get this result from the alignment from the images. And now we can see that the space is too high. So we have to decrease the space for the stitching. If you use the mask images function, you will get a very small space for this barn. So I do not recommend it for Terra images. It's only for small 3D objects. So I guess this is quite enough. We will render now these images and calculate a model. I used the standard size, normal quality. Let's go. Calculated model. We can see it's quite a very good quality. I do not simplify Reality Scan. I do that in Blender. You can see that in my previous videos how to do that. In Blender we have better quality to downsize the final image. So I let this image at the full resolution. I have 52 million triangle with the standard calculation of the model. If I would make a calculation in high quality, it would be even more, but we don't need that. So it's quite amazing, this result. Now what we do next is texturing the model. So do not use the simplify tool here. I use the simplify method from Blender. It's much more precise. Now I will texture the model. Now we got the final model. And there are a lot of details. Also this roof here is very complicated. I take always the same barn to compare the stitching methods and the aircrafts, the cameras. But this result is quite interesting. Now let's see how we will work with DJI Fly. We load our mission. I created these missions with the map creator. We will first start with the double helix. Double helix has 180 images and gives us very good 3D results. We saw it in the Reality Scan. I used a double helix, a single circle and a 2D mission. with elevation. The big advantage of the Mavic 4 Pro is that we have about 40 minutes flight time, so we can do several missions, and we can choose between the 25 megapixel or the 100 megapixel camera image size. I tested the 100 megapixel, but I got a lot of troubles with Reality Scan or even Agisoft Metashape. They have difficulties with this image size. You can calculate a 3D image with the 100 megapixel camera image size, but it takes much more time to do it and the result is not better. I use a 512 gigabyte SD card, so I have enough images to do several missions. We saw now the double helix and the single circle mission. And now I go around the barn. Now we will have a look how we can create these missions. I added some new features in the map creator, and we will first start with a simple 2D mission. So we are in 2D mode and here are the settings. I added new the NED dataset from North America for 10 meter resolution for the elevation. You can also use GPXZ with an API key, and we have like before Google KML. If you like to save your mission for Litchi or for HDR Pano, you can save a CSV file and then import it to Litchi Pilot. So for starting I changed to satellite. So I'm interested on this location here, and we will create first a very simple 2D mission. Now here we can change the distance. Actually I'm at an altitude from 56 meters. And I have an overlap for the camera for 66%, which is not enough. So I have to decrease the distance from each image. Something like that. And you can also change the heading. And we can add a cross pass. So actually I'm about 146 images, and this is a flat mission. If we click on the waypoint, we see that we are at 60 meters everywhere. And this is the last point of the mission polygon, and this is the start point. Now I will add elevation for this mission. So we can see it's quite a steep terrain here. And I can also change now the altitude. And you can see it's a flat mission. So what we can see here, I take only the elevations of these polygon points, and then all the inner waypoints are calculated with interpolation. I'm actually on the dataset from GPXZ, and I will add now some more complexity. So we will triangulate, but if we will triangulate, we have first to analyze this mission. So we have here an altitude from 105 meters, and here we are about 49 meters. And this is the 46 meter. It always indicates the lowest point to start the mission. Now, if I go to the settings, I will triangulate my mission. And now you can see we have a much more Terra-like mission. If you like to reset this view here, you can double click on this window and it will reset the 3D view of the mission. So that's the advantage to use triangulation. Also the inner points here, they are interpolated, and I can now change also distance. I can change the heading without recalculation of the elevation from each waypoint. And we can also change altitude from the whole mission. Now if we switch to pilot to KMZ, I have a distance trigger, and it will only calculate these waypoints here, and between the lines, this point, and this picture, this is made with a distance trigger. This is not possible with DJI Fly waypoints. It's only possible with DJI Pilot. You can also use the distance trigger for DJI Pilot, or you can use the DJI Fly cam set, and there each image is also a waypoint. Now actually we are about 199 images. What we can do now, it's you can transform it to waypoints, so we can no longer modify this mission. Now we have waypoints, and now what you can do is to add a very precise elevation for each of this image. Now you can see we have also here adaptation to above ground level for each of this point, and we can see that it's very steep here behind, and we have everywhere the same distance from 35 meters to the ground. Now what we can do at this moment, we can change the overall altitude, and for each waypoint we have the right altitude from the start point. You can no longer change the heading or the distance, as this is now transformed in a above ground level waypoint mission. Now what I will do is recalculate a mission. I go back to 2D mission. I will do the same without triangulation. So now I have a flat mission without elevation. I will transform this mission to waypoints. You can see it's a flat mission. And now I will add the elevation. We have a limitation. If we have more than 100 waypoints, we can not use open Topo data here. We can only use a dataset from GPXZ to calculate more than 100 waypoints. So I will do that. And now you can see we have for each image the above ground level distance. That's very interesting if you take orthophotos. So that's possible with the map creator. Now I will do something else. If you have saved a camset file from DJI Pilot, DJI Fly or another provider, we can load this file into the camset file. The camset file itself is a zip file. So I have here some camset files. You can see it's recognized as a zip file. You can open it. And now you get a WPMZ folder, and into this WPMZ folder you have the Wayline WPML, and this file we can load into the map creator. So we will do that. And now you can see this is already a triangulated mission from this rock on the Melchsee route. It's about 22 meters altitude. And now what I can do for this mission, it's, for example, if you are on the place and you have to change the altitude for the overall mission, we can change that. You can see it here. We can adapt the whole mission height. We could also add for each waypoint elevation altitudes. So that's more interesting if you are on the place, you have an old camset file and you like to modify the altitude, if you like to modify the above ground level. Not every provider can calculate a very precise above ground level emission, and for this region here it's very important that we have details. That's one of the new feature. You can do the same with a KML file. I take, for example, an ortho mission. And you can see I have here an ortho mission who is flat, and you can transform this mission into waypoints. If you have 94 waypoints, for example, we can use here, I'm in Europe, this data set, and I will add the elevation for each waypoint. So that's very important for orthophoto missions. And we can also change now the overall altitude from the above ground level for this mission. So you can now import from other providers missions and then adapt them to very precise elevation data sets. And now let's see what I use here. So it's from Open Topo data. So we have the Aster, that's from the NASA. It's all over the world, and it's about 30 meters of altitude grid. We have also for Europe, here we are about 25 meters with a precision of ±7 meters. And for this data set for North America, we use the 10 meter data set, which is very precise. If you like to use Swiss Topo with 2 meter resolution, you have to switch to GPXZ. Now let's create a new mission. This time I will use a helix mission. Helix missions are very interesting to get really high precision 3D from a building. So I will now add a helix mission, and now it's very important, you can use a flat helix mission or you can use a helix mission with elevation. I stay on Europe at 25 meter resolution, and I add the above ground level, and you can see now this mission is adapted to the terrain. Now we have some important points. Here we have a point of interest of the building. And if we are here about 54 meter altitude, we have a pitch angle from -74 degrees. Now let's change the altitude. And you can see it changes also the angle from the altitude. So if I increase the altitude, then I will also increase the pitch angle to point directly to the building. Let's do some more. Now I'm about -80 degrees. I will create a double helix from this barn here. The double helix has the advantage that we can get a very precise 3D model with a lot of details. With only 2 waypoints I define this double helix. It's actually a flat mission. And now very important, if you see these different image positions. So here I'm about 71 meters -76 pitch angle. I will change the altitude, and then the pitch angle will adapt to point always down to this object. If we go down, we will have less pitch angle. Now we can also add the elevation here. You can see it's a steam terra here, and it will also adapt here the pitch angle. If we change now the altitude, it will go back to a flat helix mission, and we have to add the elevation. So if you change the altitude, you have also then to recalculate the elevation. You can also add simple circles. Here we can change also the number of images, and also here we have the pitch angle, which changes with the altitude to always point to the target. And we can also adapt this circle to above ground level. If you change now here the altitude, it will go back to flat and you have to recalculate the elevation. It is also possible to transform a circle mission or a double helix mission into waypoints. Now we can add individual above ground level for each of this image. It's nearly a flat terra, but you can see slightly difference. If we will do the same here on this side, I will just demonstrate it. So I will add a circle here down, and we will transform to waypoints at the elevation. Now you can see the above ground level. And here I can also demonstrate the precision of the dataset. Actually, I'm at about 25 meters. If I switch to GPXZ, I have a resolution of 2 meters for Switzerland. I will add the dataset. You can see it's much more precise. If we transform a mission to waypoints, we are in a KML mission, and in the KML mission you cannot add new waypoints or change the heading or the distance. So we have to go back to the 2D mission mode and create a new mission. So what we can do with the map creator is a 2D mission, and now we will add an orthophoto mission. So I will switch to orthophoto. We can also change the angle from the orthophoto grid, but let's just see how this works. So I have 2 levels of the mission. The first level is very easy, and the second level it's at plus minus 20 degrees. And that gives us very good results with only one mission. Now what we can do is change the altitude and then add the elevation only from the polygon. And I'm at 173 images. So if you will transform it to waypoints and change the above ground level, you have to use GPXZ. But I will do that only with the polygon mission. And now we can see I adapt the mission to the terra. The red circle indicates always the lowest point from the whole mission, and that's your start point. So it's about 25 meters, the lowest point, and it goes up to 57 meters. Now if you like to add, and at this low altitude we have not enough waypoints, so we can always change the grid direction after we added the elevations, and we can also change the resolution. I have now connected the remote controller, the DJI RC2, and I use openMTP to transfer the KMZ files. So make sure that you are on the internal memory, not on the SD card. Then you go to Android, Data, DJI Go 5, Files, Waypoint. Here you can see the different missions we already created, and we have now the advantage with the cloud-based mission from DJI that we can use created missions on each device. But you have to enable the cloud upload for the different missions. So the last missions I created was the 26. We have first to create a dummy mission. I will do that. You have not to be connected to the aircraft to do that. Just choose the latest aircraft you used with this remote controller and you are capable to add a mission. So I will add a dummy mission with 2 waypoints. I will save this mission. We reload here with the openMTP control, and we can see I've created just a mission with 2 waypoints, and now we can copy our actual mission into this folder. Then we can rename the file to have the same name as the folder of the mission. Now I will explain what this means here, this UUID. This is a universally unique identifier which is created if you save the mission on the remote control, and you can not only create with this UUID a mission name and copy it to the remote controller, as the remote controller has a database, and each time it creates a UUID, it will put this in the database. So we have to create a dummy mission and then replace the CAMSET file in the folder. But it's very easy if you have a tool with openMTP. You can do that quick and easy. It's much more easier on an iPad. If you use DJI Fly on the iPad, it's very easy to do, so I'm always use that on place. If I go fly a mission, I've always my iPad with me, and with the cloud-based mission I've also the mission on my iPad, and I can change something if I like to do that on place. It happens often that we have to change the altitude to get better results from an object, and if you can do that on place, it's very comfortable. I hope this video was useful, so give it a try. And on the next video we will see how we can create a local server for geotiffs, so we can create very precise elevation. I will do that with Topo data and the map creator on macOS. Thanks for watching, until the next time.